Right, question 16. So we need to start off, we need to write this as partial fractions. So when we do partial fractions, just think about, right, I can multiply this one top and bottom by 11 minus 2p. So I've got 11 minus 2p. I'm multiplying this one top and bottom by p. So we've got BP. Oh, right, BP. Right, and then that equals 1. This is all over p 11 minus 2p, and this is over 11 minus 2p. So I can therefore say that this is equal to this. And this allows me to work out what a and b are. So you'd start off by saying, right, okay, well, if p is equal to 0, so if p equals to 0, just sub that in, and then that gives me a is 1 over 11. And then if you pop p is equal to 11 over 2, because I'm trying to get rid of this bit over here, then that gives me b equals 2 11ths. Right, so if I now write this in here, what does it actually give me? Well, it's going to give me 1 over 11p plus 2 over 11 and times that by 11 minus 2p. Now, we're going to need that again, but we'll just leave that there for a second, right? So that's the first part done, right? That's part A done. Now we need to go and think about what's going on just here. Now, we've got a differential equation, right? It tells me just there. So what that means is we're going to rewrite this part here, all right? So if I multiply both sides by the dt, multiply both sides by 22, and then I'm going to divide by this just here. What's that going to give us? That's actually going to give us this. It's going to give us 22 over p times 11 minus 2p. And it's that dp still will stay in there. And we've brought the dt over, and there's still a 1 left just there. All right. So we need to integrate this bit, we need to integrate this bit. So clearly this bit we're not too bothered about. This is the issue. But what we're going to do, look, it's very similar to what we've just done, right? It's trying to lead me through this question. If it hadn't got me to do that first, I might have been looking at this and thinking, what on earth do I go and do? So let's now go and rewrite this, combining it with this just here. All right, and see where we are. Right, I'm going to give myself a little bit of room over here. So what's that going to give us? It's going to give us 22, 1 over 11p plus 2. All I've done is just subbed it in there. 11 minus 2p. And then you need to do that. And when I know the whole thing's going to equal t. Well, in fact, it's going to equal t plus c. Right? It's going to equal a constant. So now let's go and tidy this up here. So that's going to be 2 over p, and then I can have 4 over 11 minus 2p equals t plus c. Right, now we can integrate here. So this is going to give me ln p times 2. That's actually going to, the next bit's going to give me a minus, not a plus. And we're actually going to get here, sorry, just make a bit of room there. It's going to give me minus 2. So you need to practice, make sure that you're comfortable about being able to integrate this part. So that's going to give me minus 2 ln 11 minus 2p. And we know that's equal to t plus c. Right, what else does it actually tell me? Well, I'll tell you what I will do here is I'm just going to group this together because I think this will make life a little bit easier for us. So if we can write this, just using my basic log laws, p and then over 11 minus 2p. Remember, that's still equal to t plus c. Now I need to work out what this c thing is just here. All right, so we're going to have to work that out. Well, we're told in the question that there are 1,000 meerkats in the population when the study began. Remember, it's measured in thousands just there. So in other words, when t is equal to 0, p is equal to 1. So if I substitute these in, I can find out what c is. All right? So if I just go and do that, and then you find out that c is actually equal to, that's going to be minus 2 ln 9. Right, that was just substituting these guys in. Right, so now we can write this back in. In fact, I'm actually going to add that over. I'm going to add 2 ln 9 to both sides, because then that gives me 11 minus 2p, add 2 ln 9 equals t. Hey, wait a minute, I can even combine that there, can't we? All right, so that's going to give me 2 ln 9p, 11 minus 2p. I'm just trying to think, right, how much can I tidy it up? All right, so that's really nice. Oh, what we didn't quite finish is the question was, determine the time taken in years for the population of meerkats to double. So in other words, p is 2. Okay, so if we just substitute p is 2 into here, if we just substitute to p is 2, then you'll get your t value out, and that actually gives you t equals 1.89, and that's measured in years. All right, right, now let's go and have a look at the last part of the question. So we're finished on B, right? We've done that, right? Fantastic. Now we're going to look at C. We've got to get to this, so we want to get P equals. Now we've got something, we've managed to get down to this part here, so but we want to get P equals. So let's have a little think about how we're going to do that. Well, let's divide both sides by 2. Right? I'm trying to pick out the P in here. So if we divide both sides by 2, we end up with ln 9p, 11 minus 2p equals a half t. Remember, there's always clues in what you're trying to get to. Right? I've got a half t. Well, I've actually got a minus half t, but we get to that in a minute. Right? Okay. I want to get rid of the ln. So if we just e both sides, so then we get 9p. Oops, don't know what happened to me p then. 11 minus 2p equals e half t. Right. Multiply both sides by 11 minus 2p. What we're trying to do, remember, we're trying to just write p once. So I need to get it away from being a denominator. So 9p equals 11 e to the half t minus 2p e to the half t. Right. I need to bring this over to this side. So I'm going to add it. So I've got 9p, add this part. Annoyingly, got to take the e half t with it. So it kind of makes it look like a lot more complicated, but it's all right. E to the half t. Now I can factorize. I can take p out. So p equals. So we've got 9. Oops, bracket there. What am I doing? 9 plus 2e to the half t, and that equals 11e to the half t. Divide by this, so p equals 11e to the half t over 9 plus 2e to the half t. Right, and that's, oh, wait a minute, look, I'm nearly there. But oh, it's really close, isn't it? So let's think about what I can multiply. You're going to multiply by 1. Think about what you can multiply top and bottom by. That's going to help. Well, I don't want this guy to be here. So what could I multiply it by to get rid of it? Well, what about if you multiply it by this? That would get rid of this. We can't just do that. You've got to multiply it by 1, haven't we? So we're going to have to multiply the bottom part by the same thing. So what's that going to give me? It's going to give me 11. And then I'm going to get 9e to the minus half t. And then it gets rid of this one, plus 2. Look at this. It's the same. I'm just going to write this next to it, and I'll just switch the order around the bottom as well. So that's equal to 11, 2 plus 9e to the minus half t. So A equals 11, B equals 2, and C equals 9. There you go, all done.